Assalamu alaikum wa rahmatullahi wa barakatuh. How are you learners out there in the holiday? How is the COVID situation? I'm your teacher of Geography 2, and we are here to refresh our minds, brains, because as COVID is taking us, we still have to learn. Paper 2, that is world problems and development. And today we want to look at statistics. That is section A, the compulsory area. Remember, in our paper, we have two sections, section A, then section B. Section A, we are looking at statistics, and it is a compulsory area where a learner has to maximize. This question is marked out of 25, and if you want to excel, you have got to get 25 out of 25. Before the COVID problem, we had looked at a number of statistical methods. We had looked at the cumulative line, the cumulative bar, comparative line, comparative bar, and we ended with the circular graph. Today, we want to begin from where we stopped, and we are going to look at the divided rectangle. The divided rectangle. This statistical method, like we are going to see, the pictorial appearance of the method looks like a real rectangle, and it can be used to show a lot of statistical data. Divided rectangle may take the form of, it may be a simple divided rectangle, and this one shows simple data, smaller data. Then the other is the compound divided rectangle. The compound divided rectangle. Today we want to look at the simple divided rectangle, then we see the construction procedure. And after mastering the simple divided rectangle, then we are going to look at the compound divided rectangle. So you can look at that question that we have right there. The question is right there. The question is that the table below shows major cattle ranching areas in Uganda. And the number of cattle happens to be in thousands. We have Ankole with us. It is a rich cattle ranching area. We have Karamoja, we have Kotido, we have Gulu. And each area has the cattle in thousands. The question is, construct a simple divided rectangle to portray the information above. Now, our construction procedure is going to involve steps. So, steps, the construction procedure. Procedure 1, we are going to arrange those values in order from the biggest to the smallest. So when we arrange those values, it is going to give us a table like this one. That is our area. Then this is the number of cattle it is in thousands. We are going to arrange. We look for the biggest first. The biggest happens to be Ankole. Ankole has 5, 4, 9. Then what comes second after Ankole in order? That is Kalamoja. It has 4, 8, 7. Then we shall have what comes third is we are seeing Gulu. Then the other is Koti. Kotido. We want to construct a simple divided rectangle. Step 1, I say look at the table very well, then arrange those values in order from the biggest to the smallest. Then 2, we are going to accumulate those values. Ankole has 5, 4, 9 thousands. Then we are going to add on Kalamoja. When you add 487, you add it to 549, we are getting 1036, 1036. 1036, when you add on the value of Gulu, remember has 309, so we are adding the 309 to 1036, then we are getting 1345. Then this, we are adding Kotido. Kotido in the original table, Kotido has 201. When you add the 201 to 1345, it is giving us a total of 1546. $1,546. So this is our table of results that we are going to use. This is our table of results that we are going to use. We want to construct a simple divided rectangle, and this rectangle is going to appear like a real rectangle, a real rectangle, a real rectangle, a real rectangle. We shall draw a rectangle like this. We shall draw a rectangle like that. But before drawing it, we have to first of all get the scale. How do you get the scale? We are going to use the table of results. The table of results. I hope you have this table of results with you as well, because we said that one, you look at the table that is given to you, then you arrange in ascending order, implying that from big to small. And when you look at our table that we had, the one that is showing major cattle ranching areas in Uganda, when you look at the areas or the regions, Ankole was the leading. That is why we began with it. Then when you look at the table, what comes second is Kalamoja. We put it. Then what we have done is this. We have added Ankole, which had 549. We have added it to Kalamoja, which had 487. So 487 is what we added. 487, this is for Kalamoja, it is what we added to get this 1036. Then what came third was Gulu. Gulu had 309. So we added here. We added 309 to give us this one, 1345. Then we also added 1345. We added it to the value of of quotidian, which is 201, to give us the total of 1,546. That is the construction procedure. Those are the first two steps. Arrange in order from the biggest to the smallest, then cumulate those values. And after accumulating, you come up with the cumulative table, the table of results, and it is this one. It is this one. So we are now going to construct our simple divided rectangle. Like I said, it is going to look like a rectangle, and to come up with it, you have got to get the scale. How do you get the scale? We look for the highest value. This is 1,546. We are now finding the scale, and this scale is going to be the horizontal scale. So we are getting 1,446. We divide by, this time we are dividing by 15. We are dividing by 15. Let me get my calculator. Then we see 1,546. We divide by 15. It is giving us 103 point something, 103.06. So this, we can refine it. Then we use, for example, 100. Another one may use, for example, 150. Another candidate may use, for example, 200. But me, I want to go in for 100. And how have I reached at 100? I got the highest value, which was our total. I divided by 15. Why 15? Because our rectangle that we are going to draw, the horizontal, this one, is going to be around 15 centimeters. Then the vertical, here, we are going to strictly use 10 centimeters, but the horizontal, we want to use 15 centimeters. That is why we have divided by 15 here. And once you divide by 15, like we have done it, we are getting 103. So we want to remove this 3 because it is likely to confuse us when drawing the rectangle. That's why we are adjusting to 100. We are adjusting to 100. So we are going to draw our rectangle. So we have said that the vertical 10 centimeters. 10 centimeters. You get your foot rule. It is here. Then you measure the 10 centimeters. You measure the 10 centimeters. You draw your vertical. I've drawn my vertical. You equally draw your horizontal. That is your horizontal axis. This is, for example, draw So this is the rectangle that we want to come up with. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this one we erase. Then we come here. Here, because we divided by 15, we are to have around 15 centimeters along the horizontal axis. And remember, our scale, we have said horizontal scale, 1 centimeter represents, we have agreed 100. 100 what? You look at the table below shows the major cattle ranching areas in Uganda, and our cattle happens to be in thousands. So horizontal scale, 1 centimeter represents 100. 100 what? 1,000 cattle. 100,000 100,000 cattle. So when we come here, if this is 1 centimeter, it is going to be 100. Therefore, at 2, it is going to be 200, like that. Each 1 centimeter is 100. So when we add 100 plus 100, it becomes 200. So we try to break those divisions. We break them. This is 1, 2, say 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, say 16, 17 there. We have to transfer this scale that 1 centimeter represents 100 thousands. This is our 1 centimeter. It is representing 100 thousands. So at 2 it becomes 200. 4. This becomes 6. Yes, are we there? This is 6. This is 8. This is 1,000, 1,200, 1,400. Yes, this is going to be 1,600. But remember, our total was 1,546, and our rectangle is meant to stop exactly at 1,546. How are we going to ensure that it stops at 1,546? We are going to ask ourselves a question, that if in the 1 centimeter we have 100,000 cattle, this 1 centimeter has 5 small divisions. Say 1, say 2, say 3, 4, and 5. 1, 2, 3, 4, and 5. This implies that to get the representation of the small box, you get your 100, then you divide by 5, implying that each is going to be representing 20, such that this is 20, 40, 60, 80, then 100. And that 20 is going to help us when properly demarcating off what we want to demarcate off. So I was transferring the scale that 1 centimeter represents 100,000 cattle. So even here we had to label that this is cattle in thousands. Cattle in thousands. So this is 100 thousands, 200 thousands, and we keep on adding 100. 100 plus 100, 200 plus 100, 300 plus 100, 400 plus 100, 500. The difference between each 1 centimeter is strictly 100 because that is our scale. That is our scale. We go to where we had ended. I was saying that the total is meant to be 1,546. And I was saying that we must stop exactly there. But how do we do that? If this is 1,400 plus 100, it becomes 1,000. Good. 1,500. But remember, we have this 46. We have just agreed that each small box measures up to 20. So if this is 1,500 plus a smaller box, that is 1,520 plus another small box, we have now gone to 2 smaller boxes. This is now 1,540. When I go to the other third box, that is 1, 2, 3, 4, and 5. 1,500, 520, 1,540. If I go up to this extent, that is now 1,560. But ours is meant to stop at 1,546, implying that it is in between 1,540 and 1,560. So in between there. I don't finish this third. I put in between because this is 1,500, 1,520, 1,540, 1,560, and 1,546 is in between 1,540 and 1,560. So here in between, then I demarcate off. I demarcate off that, and after demarcating it off, I erase this. I erase that. I put that this is 1,540 and 46. Now, the next thing is going to be subdividing this rectangle. Subdividing it. Remember, we are drawing a simple divided rectangle. This that we have drawn is a rectangle. Here, it is 10 centimeters, and when you look at the vertical, it is more than 10. That is why it is called a rectangle. So we are now going to subdivide. When you look at Ankole, it is 549. 549. There are two options. You may use a calculator, or you may stick to the horizontal scale. If you stick to the horizontal scale, for example, this is 500 This is 500. And remember, we said that each customer box is measuring up to 20. This is 500, 20, 40, 60, 580, then 600. But for us, we want to put 549. 500 is here. 20, 40, 60. So the 49 is in between 40 and 60. So that third small box in between, that is what we take on. That is what we take on. Then you draw. I have used a freehand, but you have got to use a ruler. You have got to use a ruler. And what is this that we have drawn? That is ankole. Then you label. That is ankole. If you want to use the calculator method, you do like this. What we want to represent is 549. 549. We divide that 549 by our scale, which is 100. Then we are getting 5.4 centimeters. 5.4 centimeters. Let us check whether we are still very accurate. This is 1 centimeter, 2, 3, 4. This is 5.2.4. The answer that we got is 5.49. So this is 5, because this is 1 centimeter, 2, 3, 4. This is 5.2. Each of the small subdivision of a centimeter mathematically measures up to 0.2. That is why if this is 5.2.4, yes, because each small subdivision of a centimeter is mathematically 0.2. So the 5.49 is still there, and we have demarcated off and we have labeled. Then we go to the next, that is color moja. It is 1036. Remember, we are using the table of results. The table of results, that is our accumulated table, the one that we generated after adding those values. That is the table that we are using to draw. Not the original table that was given to us, no. We are using the table of results. We are now transferring our results to come up with a rectangle. So we go to color moja. In the table of results, color moja is 1036. We divide that by the scale, and our scale is 100. We are getting 10.36 centimeters. This is now the calculator method, but we shall still use the other, the one that you refer to on the scale. We are getting color moja 10.36 centimeters. These are 2, 1, 2, 4, 6, 8, 10. Yes, the answer is 10.36. We have agreed that each small box is measuring up to 0.2. So 0.2, 0.4, 0.3 is going to be in between there. So you demarcate off that and you draw a line. You draw a line. Let me make it a little thicker. This is This is Karamoja. Then we go to what comes third, that is Gulu. Gulu is 1345. We can use this horizontal scale as well. If this is 1200, this is 1300, for us we want to represent 1345. Each small box we agreed, each small box we agreed measures up to 20. So this is 1300. When you add one small box, it becomes 1320. You add on another small box, it becomes 1340. And we have not finished our data because the data is 1345. When you go to the third small box, it becomes 1360. It is now in excess. So we look for the middle position, a point like that. In between 1340 and 60, that is where the 1345 lies here, because this is 1320, 340, 360. Do you want 360? No. Do you want 1340? No. We want 1345 here, because this is 1300, 1320, 1340. We almost reaching. Then this is 1360. So in between there is where we plot. And this is now our Gulu. That is now our Gulu. The last one is obvious. That is our Kotido, which is 1546. That is Koti. That is Kotido. So we have drawn our simple divided rectangle. Because we have labeled each segment, there is no need of shading. But if you want to come up with the key, then you can get the different formats of shading, and each shading format, you generate a key. You say that key how many are they? 1, 2, 3, 4. 1, 2, 3, 4. Where you see AA, that is, for example, Ankole. And if you have come up with a key, there is no need of labeling up. Then here you may say that the shading pattern I am using is letter K. Then you come onto your key. You say that where you see K, that is Kalamoja. And if you shade like this, no need of labeling up. Then Gulu, we make sure that let me use Gigi. Then on your key, you put G, that where you see G, that is glue, and if you have shaded, then no need of labeling on top. Then Cotido, you may say that, let me use D, letter D. I say that where you see D, that is Cotido. And like we have said, if you have shaded, you provide the key, then no need of labeling on the segment. One may say that, what if I do both and I shade, I provide the key, and I still put Ankole? No problem. No problem, but you are repeating yourself. Still that I have shaded, I have provided the key, but what if I still write that color moja? No problem. That this is good. No problem. That this is Cotido. No, no problem. But I said that if you write, if you label on top of those segments, then no need of shading. Therefore, you will not have to provide the key. If you do both, no problem, you are still accurate, you are still correct. Now, this is our simple divided rectangle. And every statistical method that you come up with, it must have a title, it must have a scale, it must have a key, stroke labeling, and we are going to ask ourselves a question. Have we put the title? Not yet. Have we put the scale? Yes. Have we generated the key? It is there. So what is remaining is for us to put the title. Our scale is here, but let me put it somewhere here such that I create space for my title. Our scale is, and it is the horizontal scale, 1 centimeter, REP. REP implying that represents 100 in brackets, 1,000 cattle, 100,000 cattle, 100,000 cattle, 100,000 cattle. And this scale is what we transferred here, because this is the 1 centimeter. It is representing 100,000 cattle. And we kept on adding 100, because 100 plus 100, it gives you now 200. 200 plus 100, it gives you 300. Plus 100, you get the 400,000 cattle. Here, we have got to be consistent. We add the same value that we have agreed to use. And our agreed value is 100, and that is our scale. And that's why we have kept on adding 100, 100, 100. So we put our title like we have agreed. The table was showing major cattle ranching areas in Uganda, and our cattle was in thousands of heads of animals. This title, as we are writing it, if you put it in small letters, as a must, you have got to underline it. If you put it in capital letters, you may not need to underline it. And that title should be on top of what you have constructed. So we say a simple divided rectangle showing major cattle ranching areas in Uganda. Major cattle ranching areas in major cattle ranching areas in Uganda. Like I have said, if it is in small letters, then as a must we have to underline it. If it is in capital letters, then one may not need to underline it. Mine is in small letters, then I have to underline it. So that is our simple divided rectangle showing major cattle ranching areas in Uganda. Now, after constructing, we are likely to have other questions that come along with the construction. These questions will begin with part B, giving of the advantages and the disadvantages of the method. They will say, for example, that what are the advantages of the statistical method that we have drawn? We have drawn a simple divided rectangle. If they say, what are the advantages? Mention the merits. They are looking for the advantages. Mention the reasons as to why method is most suitable. They are looking for the advantages. So either advantages, merits, or reasons as to why the method is the most suitable. There, if they say what are the advantages of the method, you say that, for example, 1, the method is easy to draw. Easy to draw, stroke construct. Like you saw, the construction procedure, it didn't have a lot of calculations. What we did was only adding up a few values after arranging our table in ascending order from the biggest to the smallest. Then we added. That addition, the accumulation of the values wasn't very hectic, and even the construction procedure was easy. So we say advantages: 1, the method is easy to draw, stroke or construct. Then 2, the method is easy to read, stroke understand. Easy to read, stroke understand. When you look at this rectangle of ours, you can easily tell that in Uganda, the major ranching area happens to be Ankole because it has the largest segment. Then maybe the least cattle ranching area is Kochido, because when you look at the rectangle, you clearly see that Kochido has a small segment compared to Ankole. So the method is easy to read, stroke understand, stroke interpret. Even to a layman, when you look at this, you can still see that this is the biggest. Now that we are looking at major cattle ranching areas, biggest cattle ranching area. This is the smallest cattle ranching area. The method is easy to read, stroke understand, stroke interpret. Then it is also good for comparison. You can compare the different regions. So there we say that it is good for comparison purposes. One can compare between the different cattle ranching areas. Then still, the method can be superimposed onto other graphs. Then still, they may look for the disadvantages of the method. They may say, what are the Roman 1 merits Then Roman 2, demerits of the method. The demerits of the method, we are now looking at the disadvantages of the method, or the reasons as to why the method is not the most suitable. The disadvantages, the demerits, or reasons as to why the method is not the best suitable, or the limitations of the method. They may use this other term, limitations of the method, limitations of the method, limitations of the method. They are looking for the disadvantages. They are looking for the demerits of the method. Limitations of the method, disadvantages of the method, demerits. There we are looking for the reasons as to why the method is not the most suitable. Here, one may say that getting a scale and a suitable scale is hard in case of a large amplitude. Getting a suitable scale is hard in case of a large amplitude. Amplitude, we are referring to now our range, implying that in circumstances when you have got your cumulative table and some values happen to be big, yet others are small, that difference in the values that you have got, that is now the amplitude, the range. Where you have some big values and extremely small values, getting a suitable scale becomes hard. That is disadvantage number one, that getting a suitable scale is hard. Why? In case of a large amplitude. Then two, we are going to still see another limitation of the divided rectangle. We are going to see that drawing and subdividing of the different segments of the rectangle takes time. It consumes time. It takes time. It consumes time. Another one may say that it is tiresome. Drawing and subdividing and shading the different parts of the divided rectangle is time consuming. Not time wasting, no. It is time consuming. We have drawn the rectangle. After drawing it, we have subdivided. After subdividing, we have labeled. All of this takes a lot of time. So we say drawing and subdividing of the different component parts of the rectangle takes a lot of time. Then still, three, we say drawing and subdividing the different component parts of the rectangle is tedious, or it is tiresome. Drawing and shading the different component parts is tedious, or it is tiresome. Normally, that part will go in for 5 marks. 3 for the advantages or the merits, then 2 for the disadvantages or the demerits. With the advantages, you don't give a reason as to why, say, the method is easy to draw. No, you stop there. The method is easy to draw. Why? We don't give a reason. The method is easy to read. Why? We don't give a reason. But when it comes to the disadvantages, we have to attach a reason as to why. For example, like we said, that finding a suitable scale is hard in case of a large amplitude. Then, disadvantage 2 is all about time consuming. The method takes a lot of time. Why? Because it involves drawing and subdividing the different component parts. Then 3, the method is tiresome or tedious. Why? Because it involves coming up with a cumulative table, drawing the rectangle, then subdividing it into different component parts. That is what it requires. For the disadvantages, each disadvantage that we make mention of, we have to attach a small reason. We give a small explanation as to why the disadvantage happens to be the way it is. What makes it to be a disadvantage is hard to get the scale Y in case of a large amplitude. The method is tiresome to draw because it involves drawing and subdividing the different component parts like that, like that. So in brief, that is our simple divided rectangle. We say the construction procedure involves the following steps. Step 1, you study the table that is given to you. We are now making a recap of what we have looked at. We are making a summary of what we have looked at. The construction procedure of coming up with a divided rectangle involves the following steps. We are looking at now the procedure that you have got to follow when drawing the simple divided rectangle. Look at the table that is given to you. Study 8. Is the table in thousands or not in thousands? Take note of that. Then 2. Arrange those values that are given to you in ascending order from the biggest values to the smallest values. Here, when you look at our table that we had, the table is all about major cattle ranching areas in Uganda. And Ankole was the first. So in our table of results, we wrote Ankole first. Then what came second was Karamoja, we put it there. What came third was Gulu, we put it there. Then it had to end with Kotido. And after putting those there, then you begin now accumulating. You begin accumulating. Allow me rub here as I make the recap. Because that simple divided rectangle is going to give us a foundation to our second type of the rectangle, what we call the compound divided rectangle. Simple divided rectangle shows simple data. Then the compound divided rectangle shows a lot of data. It accumulates more data. So I was saying that study the table, and after studying it, to arrange in order. So I'm now making a summary of how we came up with our cumulative table. This is our table of results. Table of results. Then this is number of cattle in thousands. I said that after looking at that table, then study it such that you internalize whatever is hidden there. So we have studied our table, we have arranged in order. What comes first is Ankole. We are now arranging in order from big to small. After Ankole, which is the biggest, what came second in terms of the size was Karamoja, followed by Karamoja. I am now also looking at our table. Karamoja. What came third was Gulu. Then finally, Kotido came last. Ankole was 549. This initial value, you leave it there. We are going to add Karamoja's value to the value of Ankole. So Karamoja, like I said, Karamoja was 487. So we get the 487 plus Karamoja, 487 plus 549 to give us 1036. 1036, we add on the value of Gulu, and Gulu has 309 to give us 1345. 1345, you add on Cotido, and Cotido has 201 to give us 1546. 1046. Then from here, we have said that get a suitable scale basing on the total or the biggest value. To get the scale, we have said divide this by 15. This time we are dividing by 15. Why? Because we want our rectangle to be, for example, here around 50 centimeters, yet here it is going to be around 10 centimeters. Because we want the horizontal to be 15 centimeters, that is why we have got to divide this by 15. So this, when you divide by 15, we got 103 point something. Then we said that this 3 is likely to confuse us. Then we settled at 100. But remember, our cattle was in thousands. That is why we said that scale 1 centimeter represents 100 brackets 1000 car, 100,000 cattle. Why 1000 cattle? Because our table was in thousands. If the number of cattle was not in thousands, then this wouldn't have been there. It wouldn't have been there. I would simply say that 1 centimeter represents 100 cattle. Had our table not been in thousands, had it been set in millions like this, 1, 2, 3, 1, 2, 3, similarly, even our scale was going to change. We would say that 1 centimeter represents 100, then in brackets we put those 6 zeros. Hope we are understanding that. Had it been said in had it been said had it been said in millions like this, that the number of cattle is in millions like this, then even here we would still put millions. We would still put millions, but ours was in thousands. It was in thousands, 3 digits. That is why even here it is in thousands. That is what we have in the table. So you transfer this scale, you transfer it. If 1 centimeter represents 100, then you measure. This is the 1 centimeter, 100, 2 centimeters, it becomes 200 until when you finish and you come up with the simple divided rectangle. After drawing, you remember to put the title like we did, you put the key, and you perfect your work. That is for today. In our next session, we are going to look at the compound divided rectangle.